okay? So iron 3 chloride. Iron is Fe3 positive, and I know that it is going to react with chloride at -1, so FeCl3 plus sodium hydroxide, just simply NaOH. Okay, what kind of reaction is this? What kind of reaction is this? Double replacement, okay? So iron and the sodium, are going to switch out, okay? So iron 3 positive is now going to combine with, iron 3 positive is going to combine with the sodium hydroxide, and sodium chloride are going to get together. But I know that sodium and chloride, when they get together, group 1 ions, are all aqueous. So using a solubility table, you will find that iron 3 hydroxide is actually going to produce a solid. Which one is the precipitate we're looking for? Mitchell. Mitchell. Okay, so this is what we're eventually, at the last part of the question, going to be looking for. Okay? All right, what's the other step we need to do here still? Let's balance it.
Yeah, good call.
Yeah, I love balancing. Okay, so this now is balanced. So now you fill in your known and unknown information, and what you'll find is that all of a sudden you have two things being listed on your reactant side of things. Okay, so when you have both of your reactants with information that's there, this is how you know you're dealing with a limiting and excess reagent question. Okay, so this is going to be 40 grams per mole. Okay, iron 3 chloride. Okay, double check me on this one. 162.20 grams per mole. Yeah? Yes? One person got it?
Yeah.
2 person got it. Cool. Okay. All right, so it's probably also handy to also calculate out your molar mass of your unknown, just to get all of them out of the way already. Okay, so also check me on this one. It's 32. Oops.
Did you just find the molar mass?
Yeah. Oh, plus 12. Wait, plus 4. 106.88. Anybody get that?
Yeah.
1,
Yeah.
2, 3. Okay, so what's our first step?
Find more.
Figure out your ends of each other. However, keeping in mind, sodium hydroxide has how many moles of it technically? 3 amount, right? Okay, so N equals 26.8 grams per mole, or grams divided by 162.2 grams per mole. So this is the number of moles based on 1 FeCl3. So I am going to leave that one alone, okay? So I will get 0.16522 something or other moles. Okay, now I do the exact same thing to my sodium hydroxide, but what's my last step technically going to be? Divide it by 3 to get them comparable to each other, because I have I want 1 of each, not 3 and 1 of each, right? Okay, so I get 21.5 divided by 40, so I will get an N of 0.5375 moles, okay, but that is according to me having 3 sodium hydroxides. I want to first make sure that I know that they're comparable to each other, okay? So what's my next step after that? Divide it by the 3 moles of the sodium hydroxide that I kind of want to get rid of. So I want to be able to compare either or between each other in this sense. Okay, so which one is my limiting reagent here? FeCl3. How do I know? It's the one with the smaller amount of moles when they're compared to each other one-on-one. But then this guy here is what then? the excess, okay? So this is the excess amount, okay? So the first part of the question is asking which reactant is in excess and by how much, okay? So because they're now comparable 1-to-1 between each other, I'm going to take the difference of how much of that gets eaten away. Okay, so that means I'm taking my excess minus my limiting reagent. Okay, so I take my 0.179, sorry, am I off the page? Yeah. 166 moles minus 0.16522, because that's how much of it is going to be left behind. How many red bricks do I have left? Okay, so I'm going to get about 0.0139 something or other moles. Okay, so that's how much is going to be left behind based on 1 mole of substance. But technically, how many sodium hydroxides do I actually have? I have 3 times the amount. So my first step is now to back calculate to what my original amount actually is. And I'm going to multiply this back up by the 3 that I originally divided it by to figure out how much of that is actually going to be applicable to the actual sodium hydroxide that I have in this reaction based on 3 moles of sodium hydroxide. Okay, so I'm going to times this by 3, and my N is going to be 0.0418 moles of actual sodium hydroxide in this particular reaction. And then my last step is simply timesing it by the molar mass to find out how much mass is left behind. Okay, so 1.67 grams of leftover sodium hydroxide. Or so, yeah, aqueous, sorry. Okay. All right.